Welcome to The Explainer. Today, we're going to pull back the curtain on the invisible architecture that powers our entire digital world. I mean, from sending an email to streaming a movie, it all relies on the principles we're about to break down.
Have you ever really stopped to think about that? How that little device in your hand can just pull information from a server thousands of miles away in like a few seconds? It feels like magic, but it's not. It all boils down to a concept we use every single day, usually without a second thought: the computer network.
All right, so here's the plan for our explainer. We're going to start with the absolute basics. What even is a network? Then we'll see how they scale up, look at the actual hardware that makes it all work, and finally, we'll uncover how the internet uses its own kind of address book to get data where it needs to go. Okay, first things first, let's start with the most fundamental building block of all digital communication. I mean, what are we even talking about when we use the word network?
At its heart, it's actually super simple. A network is just two or more devices hooked up so they can talk to each other. And the whole point is sharing, whether that's sharing a file with a coworker, a printer with your whole family, or an internet connection with all your gadgets. If it's sharing, it's a network. Simple as that. Okay, so now that we get the basic idea, let's see how this thing scales. I mean, how we go from the stuff on your desk to a system that literally covers the entire globe. We're going to start small. Really small. We're talking about the Personal Area Network, or PAN. This is basically your personal tech bubble. Think about your smartphone connecting to your wireless earbuds, or your laptop talking to a wireless mouse. It's close range, it's personal, that's a PAN.
Now, let's zoom out a little to the local area network, or LAN. This is probably the one you're most familiar with. It's your home Wi-Fi network, or the one at your office, connecting all the computers, printers, and phones inside a single building or on a campus. It's bigger than a PAN, but still pretty local.
And if we zoom out even more, we land on the Metropolitan Area Network, or MAN. A MAN connects a bunch of different LANs across a bigger area, like a whole city. A perfect example would be a company that has offices all over town, or even the cable TV network that serves your entire community.
And finally, the big one, the Wide Area Network, or WAN. This connects computers across huge distances. We're talking countries, continents, the entire planet. And the most famous example of a WAN? The internet itself. You actually switch between a LAN and a WAN every single day when your phone leaves your home Wi-Fi and connects to your cellular data. All right, so we've got the different scales down, but what's the actual stuff that makes these connections happen? Let's meet the unsung heroes of our digital world. Now, there's a lot of gear involved, but these are the real heavy hitters. Let's just quickly break down what each one of them does.
First up, the modem. And its name literally tells you everything it does: modulate and demodulate. See, your computer speaks digital, ones and zeros, but the internet signal coming into your house through a phone or cable line is often analog. The modem is that essential translator that lets these two totally different languages talk to each other.
Now, this is where things get really interesting because it shows how networks got smarter over time. Early on, you had a hub. Think of a hub like a megaphone. It gets some data and just screams it out to every single device connected to it. A switch, on the other hand, is way smarter. It's like a postal worker who reads the specific address on a letter and delivers it only to the right mailbox. It makes everything way faster and more efficient. And that brings us to the router. So if a switch is like the mailroom clerk for one building, the router is the traffic cop for the whole internet. It's the smart device that connects your entire local network, your LAN, to the massive world outside. It gets data packets and brilliantly figures out the best possible path for them to take to get where they're going.
Okay, so we've met the players, but how you arrange them on the field, how they're all physically wired up, is also a super important choice. We call this physical layout the network's topology.
And here are two of the most common ways to set things up. On the left, you've got the bus topology. It's simple. Every device just connects to one main cable. But it has one big weakness. If that main cable breaks, the whole network goes down. On the right is the star topology, where every device gets its own line to a central point, like a switch. This is way more robust because if one cable breaks, everyone else stays online.
All right, for our last section, let's figure out the magic trick. How does a tiny piece of data know exactly where to go in this absolutely massive global system? Well, it all comes down to having a really clear addressing system. So check this out. Every single device on a network actually has two addresses. First, there's the MAC address. Think of it like a permanent serial number that's burned into the hardware when it's made. It never, ever changes. Then there's the IP address.
This one is temporary, and it's assigned when the device joins a network. So the MAC address is like your device's unique identity, and the IP address is like its current mailing address.
But wait a minute, that brings up a really good question, right? Computers need those numbers to find each other, but we humans, we're much better with names. I don't type a string of numbers into my browser, I type a website name. So how does the network bridge that gap?
And the answer is this absolutely brilliant system called the Domain Name System, or DNS. Honestly, the easiest way to think about it is like a giant shared phone book for the entire internet. Its one and only job is to translate the website names that we understand into the IP addresses that computers need. And this whole process, this quick little lookup, happens in the background in just milliseconds, every single time you click a link or type a web address. It's the invisible translation service that makes the internet actually usable for all of us.
So we've seen this incredibly logical system, right? The hardware, the rules, the addresses. It's all built on precise, cold logic. But here's the twist. This perfectly logical system is used by us, humans, and we don't always run on logic. This quote points out that while the network follows all these technical rules, it's our own psychology, our human operating system, that decides what actually gets sent across it. At the end of the day, this whole amazing architecture, from the tiny pan on your desk to the global WAN, from the modem in your home to the DNS servers all over the world, it's a tool. It's a tool designed for one thing: connection. Understanding how it works is incredible, but the final question isn't just about the technology. It's about us. What will you build with that powerful connection?